About another interesting topic in agentic AI platform. We know that AI agents and LLM systems are quite buzzword in these times. And there is one thing we might always think why GPU processing machines are more favorable for this AI computation works. Why not the most powerful CPUs is not performing well in the AI agent or LLM system processing. So we are going to look into that aspect. Why not CPUs and why GPUs used in the AI processing or AI calculation? To know this, we also needs to know the fundamental working of AI systems or large language model systems. So we are going to deep dig deep into little bit of this AI systems and LLM systems, and then we'll come to why GPU is more favorable for this particular operation. And before we jump into the LLM systems, I want to share with you one tips. Whenever we think that AI topics are very complex, just think about our human brain. Okay, most of the AI process and most of the computational process challenges are solved similar to how our brain functioning or similar to how human system and human society is functioning. Okay, I will give you examples when going through these videos, and I am going to use this particular slide and this particular idea for my upcoming videos whenever we are explaining a complex AI process. So just think about human brain, human process, human system when it comes to AI systems, then it will become very easy to understand. So we'll continue. So the left side is how our brain functioning whenever we learning something or whenever we get trained on it. Okay, so we have a learning process, and whatever things we learned, we see and we observe will be stored in our brain, and it will get processed, and then we produce some output. It could be a story or imagination, or we giving a reply to a person's questions, or might be we giving answer to some exam questions. So let's take one specific scenario that most of us came through. We all went to schools to study mathematics, chemistry, physics, psychology, maybe sometimes, and languages, like different languages. And what is the process in these schools, in the teaching system? The teacher will give us the learning materials, and we go through it, and we hear the teachers is teaching us on those subjects, and then we store the information in our brain. We also process the information, and in the exam time when the question comes, we answer those questions whatever we learned in the classroom in the last 1 year or in the last couple of years, right? Also, this is the same case for we learning any new poems or things like that. When we are answering to our questions to our parents, we take the cultural things we learned from our environment. The right side of this document is how a large language model system works. Okay, so we have a architectures. On the left side is encoding, which will process all type of input data coming to the system, and it will find the patterns, and then it will have a processing state which is hidden for the external world, and then that will, from this pattern, it will try to produce result. It could be a pattern matching, or it could be a text summary, it could be an image from the patterns that receive from the user. Okay, so this also similar to our how our brain functioning, how our brain is learning things and producing things. Now we are going to see a symbol diagram of how large language models are created. Okay, on the left side we have data. So similar to the information is given to our brain, the data information in the left side, which wide varieties of data, enormous amount of data is given to foundation model. Foundation model means it's one of the data science paradigm for large language systems. And foundation models is created using the transformer networks. We will see what is a transformer architecture and networks soon. So the data given to the foundation model, which is a special type of data science algorithm, and that will create a generic purpose large language model. Okay, so the whatever information coming out of this transformer network implementation foundation model will be generic purpose. And in order to create, so either we can use directly this outcome of this foundational model. For example, ChatGPT earlier version is just an outcome of a foundation model. But if you want to create more specific large language model systems like an AI legal system, an AI judge, AI doctor, then we need to have it trained with special data, and that will be trained on special models that is also implemented using transformer architectures, and then those outcome will be specific. Apart from that, having the generic knowledge, it will also have a specific knowledge, so it can be used for specific tasks. Now let's resonate this process with our human system. Okay, so we all went to the schools and we studied from class 1 to class 10, or higher secondary school, or initial years of university. We learned the foundation things, the basic things of mathematics, science, natural science, cosmic science, accountants, and so and so. And then after specialization in the university, we decide what special courses we need to take. Do we want to become a aerospace engineer? Then we will take a specialization in aerospace. So this foundation means in our human system is we taking the very basic school education. Okay, and here means we are specialized university and higher university education, and the outcome is you become a aerospace engineer. And if you take an accountancy specialization, you become an accountant. If you're taking an MBA specialization, a business administration course, you become a manager, right? So this is a similarity when it comes to large language model system and our human system. Now there are different types of transformers are implemented to create different types of LLM systems. One is encoder. So encoder will see only the input patterns. So that will used for filtering the inputs like email, spam filter, or anomaly detection. Then we have decoder only pattern, that is mainly output focus, that is used for text summary and chatbot. And then we have encoder decoder pattern, that is the mostly used and widely used pattern, that is used for generating text or translating one text from to different language, like that. So we don't need to go detail into that, just need to know, and most probably encoder decoder is the most used one. That information is enough for us. Now, this is a very structure of a single transformer. Okay, and we will see the LLM systems how the transformers are stacked on each other. But this is picture of one single transformer. So all this encoder decoder is within this. Okay, that was a logical representation we have seen earlier, like encoder and decoder, and this is the physical diagram of a transformer model. Okay, and where it have these different heads that will learn about those data which is coming to it, and finally it will produce the output data by going through different computational operations. Now each encoder decoder is this transformer is stacked into n number of arrays. Okay, and we cannot possibly imagine how many number of transformers are used in train a large language model, because that much high powerful transformer model networks are used and clearly stacked like a matrix to create such an array. And all this input data is fed into this matrix formed network, transformer network, and the data is processed in parallel, and the output is also synthesized in parallel and stored in the memory. Okay, a special type of memory called vector databases. Okay, so this stacking of transformer nodes into metrics is really the key point in this computation. So it's like our brain having neural networks, neurons, which is stacked. We can't imagine how many neurons we have in our brain, and each neuron is capable of processing information, but all the neurons is working parallel. It's not sequential. So our brains neurons is like each transformer, and all of the transformers are working parallel. Similar to that, our neurons is working parallel and creating, processing information and creating output. And then transformers having different actions like dot actions, which is like parallel multiplication of different input data coming, and then scaling and masking, and soft masking. I mean, after the product, after the dot production, I mean, after multiplying the different data channel, it will also drop out the unnecessary things from that calculation to narrow down which most important data, and that the most selected data will pass to the next layer of the transformer. Okay, but in the each layer you have to imagine there will be a number of transformers, and that's the reason the transformers are processing in parallel way. It's not like a sequential process, but it's a matrix parallel processing. Okay, the entire transformer architecture is the parallel processing, but we need to imagine now n dimension uh, processors or n dimension transformer networks. Okay, and each capable of parallel processing. And now let's look at the CPU and GPU. So CPU, central processing unit, used to have 4 to 8 or 12 cores, and it is usually used for serial processing. That means sequential, one by one. Okay. But the GPU, which is graphics processing unit, used to have thousands of cores, and it's used for parallel processing or matrix processing. That's the reason GPU performing well for transformer model or foundation model operations. Okay, that's the reason CPU, central processing unit, does not perform well because it's designed for serial processing. And that's why the Nvidia stocks values are increased when this AI sector is going very high and taking the markets. Now we know that GPU is winning for the moment, but there is a catch. QPU, quantum processing unit, is coming, but that's for another video. So see you soon in my next video.